Okay, here's super FRQ with derivative graphs. So before I even start this one, I'm going to go ahead and make my chart that I always make. So starting off, I have, actually let me do it somewhere else. Do it here. So I have F, and I know this is going to go decreasing, critical point, increasing, concave down, point of inflection, concave up. Then I have F prime. When F is decreasing, that makes F prime negative. Critical point is when F prime is 0 or undefined. Increasing is when F prime is positive. Concave down is when F prime is decreasing. Point of inflection is when there's a change. Concave up is when it's increasing. Second derivative, we've got nothing for these first three. Concave down is when the second derivative is negative. Point of inflection when it's 0 or undefined. Concave up is when it's positive. So that chart's going to come in handy here. All right, A wants us to write an expression for f of x that involves an integral. So this is going to be important. We're going to use this initial value that we have. So we're going to say f of x equals, we have to take into consideration wherever we're starting at. So we're starting at a y value of 3 plus our integral. The x value that goes with this 3 is a 2, so that's where we're going to start, up to x of f prime of x dx. So basically, we're just writing a formula to show you can plug in any x value, and that's pretty much what you're going to use to find it. All right, next we need to find -6. So for -6, I'm literally going to plug it into that formula that we just made. You could also just use your first fundamental theorem of calculus. So where can I write this? I'm just going to do this right here. I'll change colors. So basically we know that f of -6 is going to equal 3 plus the integral from 2 to -6 f prime of x dx. Some way you might see this also is basically this. Same thing. We've just went ahead and added that f of 2 to the other side. That's why this 3 is out here in front. It doesn't matter, whichever way you prefer. But what is wrong with this integral is that it's in the wrong order. So from 2 to -6, we really should change that. And since we're changing the order of it, we have to make it a negative out front. And it should be going from -6 to 2 f prime of x dx. So now, if I'm trying to evaluate this integral, notice I have f prime right here in my integral, and this is the graph of f prime. That just means I'm going to find the area under the curve from -6 all the way up to 2. So I'm going to find the area of this triangle and the area of this half circle. So this is going to become 3 minus, this triangle is 1, 2, 3, 4 times 2 divided by 2. And then the area of this semicircle is below, so it's going to be minus pi. Our radius here is 2, so 2 squared. It's half a circle, so we divide it by 2. Now I could really just leave it like that. I don't even have to simplify. But it's not that hard to simplify. It really should equal 3 minus 4, which is -1, minus, that becomes 4 divided by 2, which is just 2 pi. And then our next one, we need to find f of 5. So that's going to equal 3 plus the integral from 2 to 5 f prime of x dx. So in this one, I need the integral from 2 to 5, which is just going to be that triangle. So f of 5 is going to equal 3 plus, this triangle is 1, 2, 3 for its base. Its height is 2 divided by 2. So the 2's cancel out, and we end up just getting 6. Hold on, I messed up here. So all of this, my bad, was supposed to be a negative. So this -1 is right, but I should have distributed this negative to be a plus. So this would really be plus 2 pi. Sorry, don't forget to distribute the negative. All right, I'm going to erase all of that. And let's go to part B. So on part B, we got to find f of 4, f of prime of 4, and f double prime of 4. So for f of 4, I'm going to do exactly what I did on that last part. I'm going to use my equation. So it'll be 3 plus the integral from 2 to 4 f prime of x dx. So from 2 to 4, we have this weird shape. So basically here, it's going to be a triangle. So our base is 1, our height is 2, divided by 2. Then I have a trapezoid. So it's going to be 1 times this height is 2. This height is 1 divided by 2. So if I simplify this, it's 3 plus 1 plus 3 halves. So I could really change this to 6 halves plus 2 halves plus 3 halves, which is going to equal 11 halves. So we know that f of 4 is 11 halves. Now f prime of 4 is a lot easier to find because this is the graph of f prime. So I just got to look at 4 and figure out what its y value is. So if I draw a line over, I can see that its y value is just equal to 1. So f prime of 4 equals 1. And then lastly, f double prime of 4, that just means the slope of the graph at x equals 4. So at x equals 4, this slope right here, down 1, 2, over 1, 2. So f double prime of 4 is going to be -2 over 2, or just -1. right, next, find all the values where f has a horizontal tangent. So this horizontal tangent, you should automatically be thinking slope equal to 0. Well, we know that dy dx is the same thing as f prime of x. So all I'm looking for is where does this graph have a slope of 0? Which on this graph just means where are the y values equal to 0? So obviously we have right here, and right here. So all of my horizontal tangents are going to be x equals -2, x equals 2, and then notice how here 5 isn't included, so we're not going to include 5. Now let's discuss if it's a relative minimum, maximum, or neither. So a minimum is when it changes from decreasing to increasing, which means f prime changes from negative to positive. A max goes from increasing to decreasing, and f prime would go from positive to negative. And that all comes from my chart over here. So looking at this point right here, we go from positive y values to negative y values. So from positive, negative for f prime means that there's going to be a relative max. And then at 2, it goes from negative to positive, which would be a relative min. Okay, absolute max and min. I'm going to do this up at the top just because there's more room and I can look at the graph. Alright, so absolute max and min, you should be drawing this chart here. So I have x and f of x. We always got to include our endpoints. So -6 to 5. And I also have to include everywhere that we have a critical point, which in this case is -2 and 2. So now we've already found some of these points. F of -6 is what we found way earlier. We found that to be 2 pi minus 1. F of 5 we already found was 6. F of 2, they tell us right here, is 3. Then f of -2, we would find the same way that we did before. So I know that should equal 3 plus, or in this case, it really should be a minus because we're going to change the order. So 3 minus from -2 to +2. Of f prime of x dx. So from -2 to +2 was just this half. So it's going to be 3 minus pi 2 squared over 2, which will really just equal 3 minus 2 pi. And then I'm looking for an absolute max and an absolute min. So I just need to figure out where is this the smallest value and where is this going to be the biggest value. So we have 2 pi minus 1. So that's basically, let's say pi is 3-ish. So that's, let's say 6 minus 1. That's going to be about 5. 3 minus, let's say 3-ish, is about 0. And then we have negative 3 and 6. So we can say that we have an absolute min at the point, negative 2, 3 minus 2 pi. And we have an absolute max at the point, sorry, 5, 6. Because we just take the smallest y value and the biggest y value. All right, E wants to know where is F increasing, where is F decreasing. So that's when this chart comes in handy. So notice, since this is a graph of F prime, this is the only row I should be looking at. So the first thing it wants is decreasing and increasing. So it's going to be decreasing anytime F prime is negative. So if I look at when it's negative, it's going to be from this point here all the way down up to this point. So it's going to be decreasing from negative 2 to positive 2. And then our reasoning is because F prime is negative. Then it's going to be increasing everywhere that F prime is positive. So if I look up above, it's going to be increasing from negative 6 to 2, and then from 2 to 5. Negative 2, my bad. And then we would say because F prime is positive. Okay, then I need F concave up, F concave down. So if I'm looking for when it's concave up, go back to my chart. Concave up should be any time that F prime is decreasing. So let's take a look here. It's going to be decreasing from negative 6, then it stops for a second, but it keeps decreasing all the way to 0. So from negative 6 to 0, and from 3 to 5. And then our reasoning would be F prime is decreasing. So your explanation should always come from whatever your graph is based on. Then concave down. I'm an idiot. I wrote this one the wrong. Sorry. This one, concave down is decreasing. Concave up is increasing. So notice it's increasing from 0 all the way to 3. Because F prime is increasing. Okay, G wants decreasing and concave up. So let's translate this first. What it wants, if F is decreasing, that means F prime is negative. If it's concave up, that means F prime is increasing. So let's find a place where f prime is negative and increasing. So looking at this, negative and increasing has to be only this interval. So from 0 to 2. And then we say because f prime is negative and increasing. Okay, then it wants to know where does it have a point of inflection. So let's go back to our chart. Point of inflection comes from when f prime changes from decreasing to increasing or increasing to decreasing. So looking at this, it's decreasing, decreasing, decreasing. It only starts to increase right here at x equals 0. Then it's increasing again until we get to x equals 3. And then it starts to decrease again. So those are going to be our 2 points of inflection. X equals 0 and x equals 3 because f prime changes from decreasing to increasing or vice versa. All right, we need to find f double prime of negative 5. That's our first thing. So we'll go up to negative 5. And it's right here. And remember, this is f prime. So to find f double prime just means I need the slope. So the slope here is down 1. Actually, I don't even know if that's down 1. Let's just do a slope formula here. So the slope of this line is obviously down 2 over 1, 2, 3, 4. So negative 2/4, which equals negative 1/2. So f double prime equals negative 1/2. Then I have f double prime at 0. So I know this is a horizontal tangent line here because it becomes a 0 slope. That means f double prime of 0 equals 0. And then I have f prime of 2, which is going to be right here. And notice the slopes are different on both sides. So we cannot pinpoint the exact slope at x equals 2 because it changes, meaning it's not differentiable. D and E. And our reason would be the limit as x approaches 2 from the left of f prime of x, double prime of x, does not equal the limit as x approaches 2 from the right of f double prime of x. All right, J, we have g of x equals x times f of x. Find the equation of the line tangent. So I'm going to erase everything else real quick. All right, so thinking about tangent line, we need an x, we need a y, and we need a slope. They tell us x equals 2. So if I plug in g of 2 here, it's going to be 2 times f of 2. Now up here they tell us f of 2 equals 3. So it's really going to be 2 times 3 equals 6. And then I need g prime. So obviously I'm going to need product rule here because we have two separate functions. So x times f prime of x plus 1 times f of x. Then if I plug in g prime of 2, I'm going to get 2 times f prime of 2 plus f of 2. Then I just plug everything in. So if I look, f prime of 2 we just take, this is the graph of f prime. And I could see at 2, my y value is 0. So f prime of 2 is 0, which makes that go away. And I know that f of 2 equals 3. So my slope in this case is just going to be 3. So then my tangent line is going to be y minus 6 equals 3 times x minus 2. All right, h of x equals f of x minus 2x. Find the critical values of h. So that means I need to figure out where the first derivative equals 0. So let's just look. H prime of x would equal f prime of x minus 2. So if I set this equal to 0, I'm really looking for where f prime of x equals 2. So if I go back up here, I need all the points where f prime of x equals 2. Now I drew my line terribly because we can see it should also go through that point. So right here we have x equals negative 6 and x equals 3. And if it doesn't say to justify, we don't really have to. All right. So then I have P. I need to find the slope of the line tangent to graph P at the point where x equals 2. So first step, take the derivative. So it's going to be f prime, leave the inside alone, times derivative of the inside, which is 2x. So now I just plug in a 2. Oops. That should be a P. So f prime of 2 squared minus 1 is 3. Times 2 times 2, which is times 4. So let's find f prime of 3. And I know f prime of 3 is 2. So 2 times 4. P prime of 2 should equal 8.